There's a couple things we can kind of do here. I mean, if you've got a matching situation, look at the easy ones first. Something like this, easy peasy, right? It matches. How do you know? Well, this one here is a simple diamond problem. It's also a perfect square trinomial, which has perfect squares on the outside, which means you can very likely just kind of throw out an x plus 6 and an x plus 6. And I know that x and x gives me x squared, and a 6 and 6 gives me 36. And a quick check can see if that middle thing is also consistent. It's 6x plus 6x gives me that 12x. So apparently x plus 6e is the match. Okay, that works. This one here, we should recognize this as the difference of two perfect squares. Okay, those factor to conjugates, a plus and a minus that are basically the same in every other way. It has to be a plus and a minus because the outer and the inner are going to cancel out. That's why there's no middle term. The square root of that is a 3x. The square root of that is a 2. Okay, we look over there and there's my b. Now, they're reversed. I got a plus here and a minus versus a minus here and a plus. That doesn't matter. And I'm doing the work here. I guess the do you know it could happen there, but there's your b. This is another perfect square trinomial. You see these two factors that we see here. There's your 3x and your 3x and your 2 and your 2. The difference here is that this is a plus and a minus, so it produces the negative. It also cancels out that middle term. But if that were a plus and I did an outer and an inner, I'd have a 6x and a 6x. Lo and behold, there's my 12x. So a 3x plus 2 and a plus 2, there's the other perfect square trinomial, which basically leaves us with these two guys here. Okay, as you go through this process with the diamond problem and the matching, let me just kind of go through that. You multiply those outer things. You've got an outside a 36x squared and a 37x. Okay, the two numbers that multiply together to get 36, but add together to get 37. Well, it's got to be a 36x and a 1x. Those right there are basically a substitution for that. When you have a coefficient in front of here, we've got to approach it this way, and basically you're replacing 37x with these two guys. So 4x squared, and I would have a plus 36x, and then a plus a 1x. But now I've kind of taken care of those two things. Now I can say plus 9. And so it's a pairing together of these things. Here I can take out a 4x, and I'm left with an x plus 9. Now I can't really take anything out here except maybe a 1. And the reason for that, well, you'll see in a second. If I take out a 1, quote unquote, I'm left with the same thing that I have, the x plus 9. That was my goal, to make sure this and this were the same. If I remove those from both pieces, and when I say pieces, this right here is a term, or a piece, I guess is what I refer to it as. Here's the other term. If I remove that x plus 9 from each, what do I have left? Well, I have that coefficient in front and that out in front as well. So what's left is a 4x and then plus the 1. That's why the plus 1 here is handy, because you can actually see that there is something left there. And so that right there is the is this one here, 4x plus 1 and x plus 9. So that's the C. The only thing we didn't account for is the A, which if you did the same process, and you might want to try, you'll end up with the same thing there.